So with this question, you want to know about part two. So he's earned 50 tips altogether. There's 50 tips, and one of them is $25, but they've written down that it's at 15. So they're saying, what's the effect that this has on the following statistics? Well, on the mean, if it's supposed to be 25, but you only call it 15, then clearly the mean's going to be lower. I don't think you need to be so specific as what they're saying. They just said, what's the effect? Like it makes it lower. And that's because the sum of all the tips will be $10 lower, won't it? When you think about it, if it was $15 that was added in with all the other 49 tips, you'd get a certain sum. But the reality is it should have been $25 that was added in with all those other 49 tips. So it should have been $10 more than what it was. So that's where they get that $10 from. The increase would be $10, and it's $10 out of the total. Now there's 50 tips, and you could work out what each of those tips, what the sum of the tips actually is by looking at the cumulative frequency graph and seeing what happened. Well, actually, it's just a cumulative frequency graph and seeing what happened. So that's what I'm going to do. I'm going to sort that out. I'm going to go, well, there's your score, there's your frequency, there's your cumulative frequency. You've got scores of 5, 15, 25, and 35. And the frequency of the 5s is 22, 24, 24. The frequency of the 15s, as per the graph, right, it's just whatever that jump is, like from 24 up to 40. So it's 16 as given, but it's actually supposed to be 15. And then the frequency of the 25s, as it's given there, that step is, it's hard to see, but I think that's going over to there. That's going over to there, so like 48. It's going over to 48, up from 40. So as given, it's 8, but it's actually supposed to be 9 because they miscounted it. And then of the 35s, there's just the 2. That makes the cumulative frequencies, as you can see, start off at 24, and on the graph it goes up to 40, then 48, then 50. All right, so you can read off the frequencies from the steps if you want. Why you'd want to do that is you could work out what the sum, what all the tips were. You could actually add that all up. So, for example, there's 24 lots of $5, and now at the moment there's 16 lots of $15, but we know it's supposed to be 15 of those. And then at the moment there's 8 lots of $25, but we know there's meant to be 9. And then there's 2 lots of $35. So the total sum that you get, hold on, I've just got to grab a calculator to work that out. You'll get 5 lots of 24 plus 8 lots of 25 plus, 16 lots of 15 I missed, plus 2 lots of 35. You'll get $630. So it's saying she got $630 in tips, but we know that she actually should have got $640 because one of the 25ers was called 15, right? So she should have got $640 in tips. So there's a $10 difference. Now, how many tips were there? Well, if you add up this frequency column, you'll get 50, right? We know there were 50 tips altogether. And also you can see there were 50 tips here by the bottom number of the cumulative frequency or by the top of the column. So you would normally do 630 on 50 to work out the mean, but now you're going to do 640 on 50 to work out the mean. So that's where they get that 10 on 50 is the difference. There's 50 different tips, which was like obvious from the what the highest column was here. That's telling you how many it accumulated up to, 50, all 50 scores. So there were 50 tips, and you knew there was $10 more. So the sum is going to be $10 more, and you're going to still be dividing by the 50 of them when you work out the mean. So I think that's what they're getting at there. Okay, let's have a look at the next one. Two events are such that PA is 3/5, PB is a quarter. Not A denotes the complement of A. So basically, not A is 2/5, isn't it? Right? The probability of not A intersection B when the probability of A union B is 3/4. All right. Here's a bit of a rule. The probability of A union B equals the probability of A plus the probability of B, but minus the probability of A intersection B. That's because, like, say you've got A and B overlapping, right? If you add them together, you'll be adding this bit in twice, so you need to minus it off in order to be fair to get the whole of what I'm shading now. To get just the whole of this thing, you need to go A plus B, but then you need to minus off A and B. Now, if A and B is 0, they're not overlapping. Well, that's great. So that's a bit of a rule that I've written there, and I think they're giving you that so you can work out what the overlap is, because they tell you at the start the probability of A is 3/5 and the probability of B is a quarter. So they're saying the probability of A is 3/5, the probability of B is a quarter, probability of A intersection B. We're going to work out, because they tell us in this that the union one is 3/4, which I put there. So 3/5 and a quarter, 3 on 5 plus 1 on 4 is 17 on 20. So this is 15 on 20 equals 17 on 20 minus this. So this guy, the intersection of A and B, is 2 on 20, or 1 on 10, if you like. So what I've discovered, if I was to draw up a bit of a Venn diagram, the intersection between A and B would be 1/10 there, right? The probability of B is a quarter. So say I make it out of 20, it's 5/20, but 2/20 is in the overlap, so it's 3/20 left there. So 3/20 plus 2/20 is 5/20, which is a quarter, which we've got in B altogether. And probability of A is 3/5, so we make that tenths. Probability of A is 6/10, so we need 5/10 in there. So we can start to fill out a bit of a Venn diagram from that. You could even find out what's left out there, because if you make them all out of 20, we've got 10 out of 20 and 2 out of 20. That's 12 out of 20, and 3 out of 20. That's 15 out of 20. So there's 5 out of 20, or a quarter, outside of everything in order to add up to 1. So that way, I can see what the probability of, well, I know the probability of not A is 2/5, but now I can do the probability of not A intersection with B just by looking at my graph. Not A is everything outside of A, but you've got to lie that over what's with B. So if I just colour the bit in that's not A is everything outside of A, and then the bit that intersects with just B, which is this green stuff, the bit where they intersect is what I'm now doing in orange, which is 3/20. 3/20 is what intersects there. Now, I might have gone a bit overboard there, but I know I've got another question to do in a tick. But I was just looking at, a bit of maths here to show you where a whole bunch of numbers and how it all fits together is. So you can get the answer that way. But I think they were probably wanting you to do it a bit more quickly. They're probably wanting you to look at the overlaps 1/10. So you should be able to do the probability of B, a quarter minus a tenth. I think that's probably what they wanted you to do. But anyway, we've got the answer there. A and B are mutually exclusive. So it's saying, what if they're mutually exclusive? Well, a minute ago, I did a whole bunch of work to find this 1/10 thing to put in the middle of my Venn diagram. Well, now I can do my Venn diagram and have no overlap, which means the probability of A is 3/5 and B is a quarter, right? There's 3/5 in there. There's a quarter in there for probability of B. And they say we want to find the probability of not A intersection with B. So we're looking for the probability of complement of A intersection with B. Well, the complement of A intersection with B is just a quarter, because you can see that from the diagram. The complement of A, or not A, is everything outside of A. And where does that intersect with B? Well, there's B in the green there. So clearly where they both overlap, where the blue and the green overlap, is B, is a quarter. Now that's 5/20ths, but that's a quarter, isn't it? So what do we got here? Series. Okay, so this series, it looks like we're multiplying by negative tan squared x to get from one to the next. It looks like the common ratio is negative tan squared x. If you were asked to prove that, or a way to find that is just to do, term 2 over term 1, and then term 3 over term 2, and you'll notice you keep getting negative tan squared x as your ratio. So it's got a common ratio of negative tan squared x. And so they want to, well, when has it got a limiting sum? Well, for a limiting sum, the common ratio less than 1. All right. So you've got your negative tan squared x less than 1. The size of that is less than 1. Now, when you work that out, then that's just like saying the minus of, because tan squared x, right? Tan squared x will be positive for sure. So negative tan squared x will be negative for sure. So these things here are going to take the negative of that. So the way they'll work is they'll take the negative of negative tan squared x. That's what we've been asked about. And we can say, well, that's then just tan squared x is less than 1. All right, the square of tan x, whatever that might be, is less than 1 is what we're looking for. So how might you solve that? Well, here's one way. Tan squared x minus 1 is less than 0. So tan x minus 1, tan x plus 1 less than 0. So we want to, first of all, let's find where tan x equals 1 or tan x equals minus 1, because that would be a nice, oh goodness, it's scrolled down. I had a minus 1 there, but for some reason when I scrolled it got messed up. So let's solve those two things. Just see if I can scroll down the page without messing everything. Oh, we need another page. Okay. Now everything's jumped. Technology. Let's just go to the edge of here. Let's insert a page break. And okay, we're down here. Anyway, we're trying to solve tan x equals 1, which is x is pi on 4, but also, you know, 3 pi on 4, and I'll have a look what sort of numbers we're needing there by looking at the top and looking at any restrictions. Determine the values of x such that the series has a limiting sum is what we're trying to find, I think. Yeah. And if you notice, they've told us x has got to be between minus pi on 2 and pi on 2. So that's why I'm not going to need to worry about those extra bits. Pi on 4 is the only one for that. And tan x equaling minus 1. So x could be, now if you're allowed to go round to minus pi on 2, then minus pi on 4 is a go. And also, if you can go to pi on 2, no, that's it. If you're allowed. So those are the only two solutions to those. Now let's just have a look at what I was talking about here, right? I'm talking about the diagram of tan squared x minus 1. What does that look like? Because it's got to be underneath the x-axis. So what do you think tan squared x looks like? Like, this isn't too big a deal, but if you go out, there's pi on 2, and there's minus pi on 2, because that's where we're restricted between. We know tan looks like that. Now, tan squared x then is going to look like this guy is going to be squared, so it's going to be, you know, it's going to go out sort of like that, let's say, and it's going to be up like that as well instead of underneath, because it's squared, so it makes it positive. And then it's saying tan squared x minus 1. So if I in blue just go down 1 unit, we're looking at this style of thing here. And I've just found where it cuts through these 2 points. I found it cuts through at minus pi on 4 and at minus pi on 4 and at pi on 4. And now the question says, where is it under the x-axis? So where is it under? Well, in this bit in here, it's under between minus pi on 4 and pi on 4. Now, say you didn't want to draw all that, what I would do is I'd just test a point then. Instead of drawing all that, I'll just let x equal 0 and see how that works out. Does that give me what I want if I stick 0 in there? Yeah, it does. So I know it's in between the two. And I might check the other points, like check somewhere out here, like pi on 6, or pi on 3, or minus pi on 3. Chuck those numbers in there just to see whether we're talking about going to the right of pi on 4 and to the left of minus pi on 4, or in between minus pi and pi on 4. So you don't really have to have a diagram if you don't want to be able to solve that. Okay, what else have we got? That's the end of those? All right, I'll send that on. Let's stop that recording.